So, we are discussing about the software controlled serial data transmission, and there is one more register called status word register. So, the format of the status register is this is also 8-bit register. This is transmitter ready TXRDY. If this bit is equal to 1, represents transmitter is ready, otherwise 0. Similarly, receiver ready. If this bit is 1, represent that receiver is ready. Then we have transmitter empty. If this bit is equal to 1, it represents that transmitter is empty. Then we have parity error. If there is a parity error, if I transmit the even parity signal and if I receive odd parity, then there is a parity error. So, this bit will be 1 if parity error occurs. Then we have overflow error. If this bit is equal to 1, in case if first character is not received before the second character is ready. If CPU or microprocessor does not accept or uses the character before the arrival of next character. As I have told, in case of 1200 baud rate system, the duration of each character will be 0.83 milliseconds. So, if one bit of the character is received, this is for the entire character. So, if one character is received, so the next character, if it is already arrived, before that you have to accept the first character, otherwise there will be error which is called overflow error. This particular bit will be 1. Then we have framing error. This is equal to 1 if stop bit is not identified. Then we have sync detector, sync/detector. This bit is equal to 1 if sync pulse is detected. This will be used in synchronization pulse is detected. So, this bit will be used in synchronous serial communication, or we can use this as break character also. And the last bit is DSR, data set ready. If data is ready, this bit will be 1. This is about the status register. So, the microprocessor can read the status register, thereby it knows the status of various signals. There are two registers, one is mode word register and command word register. The microprocessor has to write something into that one to set some specifications, whereas the status register the microprocessor will reads. Okay. So, this is about the first block, which is read write control logic block. Now, coming for the transmitter section and receiver section. Transmitter and receiver sections. This is internal bus. This is internal data bus. And we have the transmitter section here, transmit buffer, which is basically parallel to serial converter. Then we have one output register here. Then we have transmitter control logic. This entire section is called transmitter part. So, in the earlier architectural diagram, I have not shown these details. So, what are the signals for this? We know that transmit data is one signal, output signal, and there will be one input signal clock, transmit clock, active low signal, transmitter empty, then we have transmitter ready. So, these are the various signals available for the transmitter section. This is transmitter section. Similarly, in receiver section we have one serial to parallel converter. So, data that will comes enters into input register. In case of transmitter we have output register, whereas in receiver we will be having input register. This is the where the received data will be received. Then here we have receiver buffer, this will be connected to the internal data bus. Then we have receiver control logic. The signals are here: receive clock, active low signal, receiver ready, then we have sync signal. Now, coming for the functions of this transmitter ready, transmitter data, receive data and all is, so whenever this particular transmitter is ready to receive the data, So, it will interrupt the microprocessor. So, the microprocessor places the data on the data bus, that data will be here placed, that will be converted into output buffer. So, the function of this transmitter ready is, whenever the transmitter is ready, so it will request the microprocessor for data, then the microprocessor writes the data. So, after that this data is transferred to the output register. So, if this output register is pulled, if it is placed with the data, then transmit data, this will be converted into a serial data and that will be transmitted here. So, if this output register is empty, if this is empty, then transmitter empty signal will be high. As long as the output register is filled with the data, this transmit empty will be 0, otherwise transmit empty will be high. So, this is about the function of transmit ready, transmit empty, transmit data. Then the clock will be, so this clock is going to decide the rate of transmission. Normally the transmitter and receiver clocks will be, normally it is 1 time or 16 or 64 times that of baud rate. This can be decided by using the mode word register that I have discussed in the previous slide. So, the last 2 bits of the mode word register is, it is going to select the baud rate factor 1 or 16 or 64. So, normally the clocks of transmitter and receiver will be, so it can be same as the baud rate or 16 times baud rate or 64 times baud rate. And similarly here receive ready. So, the microprocessor what happens is, it will check this receive data. So, whenever receive data is 0, because the starting pulse is start pulse, normally it will be 0. Then this microprocessor will wait for half clock cycle. Again it will check RX D signal. If it is still 0, that means it is a proper start bit. So, the microprocessor will accept this data, whatever the data that is received, onto the input register. The data available on RxD is taken into input register. That serial data will be converted to parallel by using this receive control logic. Then sync will be to check for the sync pulse, like here in case of asynchronous, this is in case of asynchronous, we will check for start pulse, whereas in case of synchronous we will check for sync pulse. And transmitter, whenever transmitter is ready, let us say whenever receiver is ready, so we will check this receive data. Okay. That is about the functions of the various signals associated with transmitter and receiver. So, you see them in sorry teacher details of 8251. Now, we will take some examples. So, I want to connect interface RS232 C to microprocessor using 8251. So, what are the details. This is 8251. So, in the last lecture we have discussed how this 8251 will be connected to RS-232 interface. Now, we will show this microprocessor connections also. This is your microprocessor. Which is 8251. So, basically you have to find out what is the chip select signal. So, I am going to use an AND gate output. The inputs of this one I will connect to A1, A2, A3, A4, A5, A6, A7. A1 to A7, totally 7 signals, here 1, 2, 3, 4, 5, 6, 7 signals. So, A1 to A7. A0 I will connect to C by D bar of 8251. I will connect this read bar, write bar to IO read bar, IO write bar of microprocessor. This is IO read, IO write. I will connect to write bar, then reset out to reset, reset of microprocessor to reset of 8251. So, clear to send, it is ready to send. I will make as 0 and this is ground and this is clear to send bar. So, whenever this is ready, then it should be 0. So, I will connect to the ground point. The other side we have the serial data that can be transmitted. I have to connect through, this is transmit MC1488. I have discussed in the earlier lecture. The purpose of this IC is 8251 operates with TTL levels, whereas RS-232 interface will have different levels. So, in order to convert the TTL levels into the levels which are compatible to RS-232C, we will use this MC1488 IC, and this will be connected to RS-232 interface. I will show only 3 signals. This is transmit signal 2, 3, 7. 7 signal will be of course connected to the ground point. This is RS-232C cable. Then this will be again converted into for transmission. To teletype device. These are the connections between RS-232 interface 8251 and 8086. Okay. Now, what are the addresses of the mode word register, command word register, status register, and the data register. This will be decided by the chip select signal logic. So, here in order to select this chip, What should be this A1 to A7, A7, A6, A5, A4, A3, A2, A1, A0. So, this all should be 1, then only output of NAND gate becomes 0, chip will be selected. And in order to select the data register, C by D bar should be 0. In order to select any of these registers, C by D bar is equal to 1. Okay. If this is 0, this is FEH, this data register will be FEH. So, address of these 3 registers will be, this will be 1. So, remaining all this will be 1s to select the chip, this is FFH. So, regardless of these 3 registers, the port address is FFH. So, these addresses, the address of mode word, command word and status word are same, data register will be different. So, this for this particular logic, these are the addresses of data register and the mode word, command word and status registers. Now, with this connection details, this is data communication equipment. So, if you want to make transmitter ready, so for that if I write a simple program, so I will give some specifications. I want to use asynchronous mode, and I want to use character length as 7. So, asynchronous mode means we require some stop bits, number of start bits is 1 and number of stop bits will be 2, and I do not want to use the parity. So, I want to read the status of the signal till the transmitter is ready. Okay. So, read the status until transmitter is ready. So, what are the instructions to fulfill these specifications? Is first you have to write mode word register. So, what will be the mode word register? What are the last 2 bits? And I want to use another specification here is clock frequency. I want to use 153.6 kilohertz, and another this one is baud rate is 9600 bits per second. So, what are the last 2 bits? So, this is factor, baud rate factor. So, what is the baud rate factor here? So, this clock frequency should be either same as baud rate or multiples of this, okay, 116 or this one. So, we can see that here from this 153.6 divided by 16, this is 1000 kilohertz. This value will be, if I compute this will comes around 9600. So, what is the baud rate factor? This is baud rate factor. As I have told, the transmitter and receiver will be operated with either baud rate or with some factor of baud rates. Okay. So, in this particular example, what is the baud rate factor? 16. So, this is 0 0 if for synchronization mode, 0 1 baud factor of 1, 1 0 baud factor of 16, 1 1 baud factor of 64 here, because this is this one 16 baud factor, this will be 10. Then the next 2 bits are character length. So, what is the character length here? 5 bits means 0 0, 6 bits means 0 1, here 1 0 because 7 bits. And the next 2 bits are parity control. No parity means 0 0. X is 0 is no parity. I will take do not care also as 0. So, this will represent no parity. This will represent character length is 7 bits. This will represent that baud rate factor is 16. And the last 2 bits are so last 2 bits are frame control. So, how many stop bits I want to use? 2 stop bits, this is 1 1. This will represent 2 stop bits. So, what is the control word? 1100 is CAH. You have to load CAH into mode word register, and what is to be loaded into command word register. So, what is the format of the command word register? This is the command word register. So, I want to enable only the transmitter. So, this should be 1 data terminal ready. So, we are not going to use receiver. So, these bits we are not going to use, do not care. Receiver enabled, we are going to disable the receiver, because I want transmit operation. Send break characters is not required, this is do not care. Error reset. So, I want to set this error. Ready to send is not we are using. This is internal reset. So, this we have to 0. So, that if this is 1, internal reset will take place. Internal reset will take place, but I do not want to reset internally. So, 0. This also do not care. If I take all do not care as zeros, this will be 0 1 H. So, command word is 0 1 H, and status register will be. So, I want to check this, I have to check actually. So, the last bit of this one will be transmit ready. I have to check till the transmitter is ready. So, I am interested in this bit. Okay. So, now coming for this program, this is CAH. So, I will take move. What is the address of mode word, command word and status word registers? Just now I have obtained, that is FFH, and FEH is for data register. Move AL comma FFH out, sorry, move AL comma this. I want to first load CAH into the control register. CAH out. What is the address of this? FFH. FFH comma AL. So, these 2 instructions are used to load CAH onto mode word register, so that it will set the baud rate factor as 16, 7 bit character length, no parity and 2 stop bits. Then you have to load 0 1, just now we have computed H onto command word register, whose address is also same, FFH comma AL. So, this will set the transmitter ready. Okay. Now, I have to check for status register in AL comma FFH, status register also FFH. If the last bit is 1, the transmitter is ready, otherwise transmitter is not ready, it has to wait until the transmitter is ready. Okay. So, for that I have taken this, then if I write end with, you can use either rotate logic or AND logic, AND AL comma 0 1 H. So, if the transmit ready of the status signal, if this bit is 0, if I AND this, these are all do not cares. You are basically ANDing this with 0 0 0 0 0 0 0 1. So, what will be result? If this bit is 0, result is 0 0, if this bit is 1, result is 0 1. So, after AND operation, the result can be either 0 0 or 0 1. If it is 0 0, what does it mean? Transmitter is not ready, we have to wait. If this is 0 1 means transmitter is ready, then we can ready to transfer the data. Okay. Now, what is the remaining instructions? Jump on 0 up. You have to wait until transmit ready pin is 1. So, here at up we will take again the data, we will AND with this one, we will check for 0 flag. Once this is not 0 means the last bit is 1. So, if I AND with this one, we will get 0 1 which is not 0. So, this will come out of the loop. Now, we can transfer the data. Here you can write the program to transfer the data. This is how you can write the program. We can connect the RS-232 interface to this microprocessor and you can write the programs. So, we will discuss some more programs in the next lecture, probably that will be the last lecture. Thank you.